Hello students. Today we will start with computer fundamentals. We will see what are there in a computer in a very broad sense. Okay. In general, we'll see what are the components of a computer. Okay. Let me present the slide. Okay. You can see a computer system. What are computers you can see here? You can see a monitor, a mouse, a keyboard, and a system. A computer system. You can say a CPU. So this is a simple model of a computer. What a computer does, it accepts data and input through the input unit. Okay, and it stores and retrieves data and instructions to the memory or from the memory. It stores data instruction to the memory. In the same way, it retrieves data and instructions from the memory and processes data as per the instructions. Communicates this information to the output device. Okay, look at the previous one. Here, what are the input devices? What are input devices you can see? You can see a keyboard, a mouse. Through this, we are giving input. And the output is produced through the monitor. All other things are done inside this box. Okay. So this is a computer system. You can see this diagram. Here, few more components are visible. Secondary storage device, primary memory, control unit, arithmetic and logic unit, central processing unit, input unit, and output unit. Formally, we can define a computer system as a computer is an electronic device that can be programmed to accept input, process it, and generate output. That is, whatever be the input which you are getting from the user is processed inside the system and generates the output as desired by the programmer, as required by the outside world. This is what is done inside a system. A computer along with the hardware and software are known as a computer system. The hardware is not enough. We need to connect it. We need an operating system. We need the software to run this. See, in the figure, we have seen a set of components. These are all hardware. This we can touch. We can feel. They are known as hardware. But hardware is not enough to run a system. To run a system, we need a software, programs that should manipulate all these devices. That is required to communicate with all these devices. So hardware and software together is termed as a computer system. Okay. Computer system primarily comprised of CPU, central processing unit, memory, input and output devices, and storage devices. All these components function together as a single unit to deliver the desired output. That's very crucial. All these things should work as a single unit, work together. Even though they are separate components, they are mingled and work together to make the system work. Okay. Now just go through what are the functions, what are the general functions of a CPU. The central processing unit is known as CPU. CPU is an electronic circuit of the computer system that carries out the actual processing. What is done actually is done by the CPU. We can say that CPU is the brain of a computer system. CPU is also known as processor or microprocessor. Okay, CPU can be placed on one or more microchips called ICs, integrated circuits. ICs are developed using semiconductor material. Okay, this is very small. Even though we show it in big figure, the CPU microprocessor, the core is a very small thing. The main components of a CPU are arithmetic and logic unit and control unit. Arithmetic and logic unit or ALU performs all the arithmetic and logic operations. What are the arithmetic operations? Plus, minus, into, division. That's a basic arithmetic operation. What is logic operation? Comparison operation. Whether A is greater than B is greater than C is greater than D, whether this is true, whether that is true. That type of operation is known as logic operation. So all these operations are run by the ALU. What is the function of CU then? Control unit. Control unit controls sequential instruction execution, interprets the instructions, and guides data flow through the computer's memory, ALU, input, and output device. Or this is the central thing that controls all the devices. Memory, ALU, input and output. The CPU is the one, control unit is the one which controls the instruction execution. Okay. CPU is given instructions and data through programs. Who is writing the programs? Program is written by the programmer or users. Okay. They are giving programs. Based on the instructions given, the CPU is executing. So based on the instructions, it may fetch program and data from the memory, performs arithmetic and logic operations, and stores the result back to the memory. Is it clear? Where we are storing all these programs and data is recorded in memory. When we say memory, it is primary memory. Okay, we have two types of memory: primary memory and secondary memory. So programs and data should be in primary memory for the CPU to execute this. CPU gets these programs and data from the memory and performs arithmetic and logic operations as written in the program. And whatever results we are getting, it is stored back to the memory. Okay. While this computation is carried out, CPU may be required to store some of the intermediate results. So there is a small memory, fast memory inside CPU itself. They are known as registers. Okay, CPU stores data as well as instructions in its local memory called registers. Registers are local memory inside the CPU itself. Okay, this is very small. It is limited by size and number. There is a very small, CPU is very small and very fast also. Why it is required? Sometimes when we do calculations, we need to write down in a side when we are doing calculations. We used to process these calculations on one side of the paper. That's not the main thing. It can be erased. For that storage only we are using registers. Registers are used for storing data, instructions, and intermediate results only during processing. When we are processing instructions, if the CPU wants to store anything, is that clear? If the CPU is doing a set of instructions, in between, if the CPU wants to store the result or intermediate results or anything, that is done inside the register. Okay, these are the main things, main components of the CPU. CPU has arithmetic logic unit, control unit, and registers. Okay. Now just go through the input devices. We have seen some of the input devices in the first figure itself. The devices through which control signals are sent to a computer are termed as input devices. That is, the computer accepts inputs through these input devices. These devices convert input data into digital form that is acceptable by the computer system. Okay, some of the examples are keyboard, mouse, scanner, touchscreen, microphone, joystick, trackball, etc. So whenever we are using a keyboard, we are typing our input through the keys in the keyboard. When a key is pressed, so for example, we press a sequence of ones and zeros are transmitted to the computer system. That is done by the input device. We have input unit and input device. The input device means the exact device, like keyboard, mouse, scanner, etc. are known as input device. The input unit accepts input through the input device. Okay. The data entered through the input device are temporarily stored in the main memory of the computer system. The same memory where the CPU stores instructions and data. The data entered through the input device is stored temporarily in the RAM of the system. RAM is volatile. That is, the data will be there only when current is there. Otherwise, data will be erased. So it is where all the data are stored during execution. But if you want to store it permanently, we have to store instructions and data in the secondary memory, for example, hard disk. Okay. Next is output device. The device that receives data from the computer system for display, for the printer, and for physical production, etc., are known as the output device. It is through the output device, the user or we get the result. The result is produced by the system, is displayed through the output device. Okay, it converts the digital information obtained from the CPU in a human understandable form. Monitor, visual display unit, monitor or visual display unit, printers, projectors, headphones, speakers, plotters are all examples of output devices. Okay, we are seeing something on the monitor. It is a result of the it is a result produced by the computer system. So, suppose we are getting the output through a speaker. The output to speaker, that is the digital information is produced into audio signals to produce through a speaker. So whatever the output device is demanding, it is the duty of the output unit to convert into the proper form. Okay. Printer is the most commonly used output device to produce output in a hard copy form. So once we have printed, the printed output is a hard copy. It is not soft copy. So the idea is clear, no? Whenever you are seeing something on the display, it is a soft copy. But if you print it on the hardware, print it on a paper, it is a hard copy. There are three types of commonly used printers: inkjet, laserjet, and dot matrix. And there's a new generation printer introduced, which is known as a 3D printer. You might have heard about it. Have you heard about it? 3D printers. It is used to build physical replica of a digital design. Whatever design we are giving, it will be printed in a 3D form, in a physical form. Okay. Nowadays, we are using this for medical purpose also. Okay, this is some of the examples I want to show you. And have you seen this? This is braille input. You can see dots here. It's a tactile display, touch display. It can be sensed through touching. So the visually impaired persons can use this keyboard for giving input. Here also you can see this. There will be a raised dot for each of this display. Similarly, we have braille printers. That means we get embossed writing in a sequence of paper. That means raised dots on a paper. This is for braille users, visually impaired users. Okay, to summarize, input unit accesses data and instructions from the outside world and converts analog data, that is the outside world data, into digital form, supply the digital form of data and instructions to the computer system for further processing. What the output unit is doing, it accesses the results produced by the computer, which are in a binary coded form. Convert the binary coded result to human acceptable form. Supply the convert results back to the outside world. Okay, so clear? Now I'll just go through the evolutions of computer. Here in the slide, only the major findings are displayed. In between, there are a lot of findings, but only the major breakthrough is displayed. So we can say that the computing using a machine, using a device, started at 500 BC, around 3000 years ago, using abacus. Do anyone of you know about abacus? Some of you might have learned it. It is a mechanical device capable of doing simple arithmetic calculations. Okay. In 1642, Blaise Pascal invented Pascaline. It is a mechanical calculator known as Pascal calculator to do addition and subtraction of two numbers directly. Okay, it can add and subtract two numbers. But when there is multiplication division, it is done through repeated addition and subtraction. Suppose you want to multiply 2 into 3. We can do it like this: 2 plus 2 plus 2, 3 times. So multiplication is done by addition. Similarly, division can be done by subtraction. In the computer system also, we are doing the same thing. Okay, it is invented by Blaise Pascal. In 1834, analytic engine was discovered by Charles Babbage. Charles Babbage is known as the father of computing. He invented analytic engine. It's a mechanical computing device for inputting, processing, storing, and displaying the output, which is considered to form the basis of modern computers. Here also we are using the same thing. We give input, process it, store the result, and display the output. There's the same concept used even now, even though he designed it in paper. He developed a machine known as analytic engine. The same concept is still valid. Okay. In 1890, under a well-known man known as Hermann Hollerith, he invented tabulating machine. It summarizes data stored in punched card. which is considered as the first step towards programming. That is, data is stored in a punched card. I can show you the slide when we are learning about the input device. Punch card is a card with set of holes in it. This is the first step towards programming. This is the program. He devised a method in which through which we can write programs through punch cards, input through punch cards. Okay. In 1937, Turing machine Turing machine concept was invented by Alan Turing. The concept was a general purpose programmable machine that was capable of solving any problem by executing the program stored in punch card. Okay, Turing machine was invented by Alan Turing. In 1945, there are two machines known as EDVAC and ENIAC. John von Neumann introduced a new concept of stored program computer, which was capable of storing data as well as program in memory. The diagram which I have shown the first part, it is a no, John von Neumann concept. EDVAC and ENIAC computers are developed based on this concept. You can go to the slide. This function, this figure. Can you see this figure? This figure is known as the based on John von Neumann concept. Input, you have CPU and memory, you produce output. The concept. Stored program concept. The program and data can be stored in memory. That concept was introduced by John von Neumann. Now, another breakthrough in the development of computers is development of transistors. Earlier, the computer was developed using vacuum tubes. Vacuum tubes very huge. So earlier computers occupied a one big building to place this computer. Later, these vacuum tubes are replaced by transistors. Transistors very small thing. That's another breakthrough in the development of computers. Again, in 1970, ICs, integrated circuit, has developed. A silicon chip in which the entire electronic circuit can be placed using a very small area. The size of the computer drastically reduced because of this IC. Even now we are using this IC. These are some of the major breakthrough through the evolution of computers. Hope this is clear. We can stop here. Thank you.